So our topic for today is about ultraviolet visible or UV spectroscopy. So before we proceed, okay, so let's first discuss the important terms on this report. So we have ultraviolet is a form of electromagnetic radiation with wavelength from 10 nanometer to 400 nanometer. So ultraviolet is shorter than of visible light but longer than X-rays. We also have visible light between 400 nanometer to 700 nanometer. And the near infrared is from 750 nanometer to 3200 nanometer. So near infrared light is generally poorly absorbed because its photon energy is insufficient to induce electronic transition. So with this, its frequency is greater than the natural vibration frequency of most chemical bands. So that's why um, we use ultraviolet and visible light in this spectroscopy. So when we say spectroscopy is based on the interaction between light and matter. When the matter absorbs the light, it undergoes excitation and the excitation resulting in the production of spectrum. So we have here a picture showing the ultraviolet, and then this part is the visible light. Okay, it has the rainbow colors, and then we have the infrared. Okay, we have that one. So the principles of UV visible spectroscopy is based on the absorption of ultraviolet light or visible light by chemical compounds, which result in the production of distinct spectra. So when matter absorbs ultraviolet radiation, um, the electron the electrons present in it undergo excitation. So this causes them to jump from ground state. So when we say ground state, it means like at rest or small amount of energy to an excited state. Okay, so when we say excited state, it means large amount of energy. It is important to note that the difference in the energies of the ground state and excited state of the electron is always equal to the amount of ultraviolet radiation or visible radiation absorbed by it. Okay? The instrument used in ultraviolet visible spectroscopy is called UV-vis spectrophotometer. It measures the intensity of light after passing through a sample and compares it to the intensity of light before it passes to the sample. So later, we have pictures to show the intensity of light before and the intensity after it passes through the sample. So we have here, okay, a illustration or picture showing the um, parts of the spectro UV-vis spectroscopy. Okay, so we have here light source. Okay, and our light source, okay, or radiation source is often made up of tungsten filament or deuterium arc lamp and xenon arc lamp or the light imitating diode. Okay, so so that is the light source of the UV spectroscopy. So we have here the wavelength selector. So this one, okay, is um this is a monochromator or um made up of prism. So when the light source strike the prism, it creates rainbow colors, like the one in the visible light. Okay, and then we have this sample. Okay, so this object is called cuvette. Okay, so this one holds our sample. So in our UV-based spectroscopy, samples are mostly often liquid. Okay, so why liquid? Because um, if we use liquid sample, it is non-destructive, rapid method of liquid analysis, and easy to determine the absorbance and reflectance and the transmittance of light from the sample. Okay, and then we also have here detector. So this one detect the lights, okay, the lights that pass through our sample. So single photodiode detector and photomultiplier tubes are used with scanning monochromators, which filter the light so that only lights of the single wavelength reaches the detection one at a time. Okay, so we have here a computer to process the signal, okay, that we get from the or which is detected by the detector. Okay, so we have this computer. So what kinds of detector are used in UV visible spectroscopy? So as what I have said earlier, okay, the widely used detector in UV vis spectroscopy is the photomultiplier tube. It consists of photoemissive cathode, which is a cathode that releases electrons when it is hit by radiation photons. And then we have multiple diodes and anode. So we have here a picture showing the um, place or the location of the parts of the UV-vis spectroscopy. So we have here the light source in this part, okay? And then in this part, we have the sample, okay, which we place the sample. We have this one, okay? This is the sample. And then the light guide, and then the mirror, and then we have the DVDR diffraction rating, this one, and then the detector, okay? And then this detector is connected to our light source and also to the computer to process or to analyze the data captured by our detector. So we have here a picture showing the actual setup of our UV-vis spectroscopy. So we have this one is the UV-vis spectroscopy instrument, and then connected to our PC, okay, to the computer to detect or to analyze the data or the or oh yes, the data we want to gather. Spectrophotometer can be either single beam or double beam. So in a single beam instrument, all the lights passes through the sample cell must be measured by removing the sample. This was the earliest design and it is still the common use in both teaching and industrial lab. So we also have double beam instrument. So in double beam instrument, the light is split into two beams before it reaches the sample. So the one beam is used as the reference. The other beam passes through the sample and the one beam intensity is displayed is the ratio of the two beams intensities. Some double beam instruments have two detectors, and the sample reference beam are measured at the same time. Okay, so um, the reference is also measured by the detector, and then the sample, okay, the other sample is also measured by the detector to determine their differences. Okay, molecules containing bonding and non-bonding electrons can absorb energy in a form of ultraviolet or visible light to excite these electrons to higher antibonding molecular orbitals. The more easily excited the electrons, okay, the longer the wavelength of light it can be absorbed. So HOMO and LUMO. So HOMO stands for the highest occupied molecular orbitals, and then LUMO stands for lowest unoccupied molecular orbitals. So between the two, okay, the orbitals that have electrons, the HOMO is the highest in energy, while LUMO is the lowest in energy. So aside from transmission and absorption, UV visible spectroscopy can also measure the reflectance of a sample or how effective a surface is in reflecting the total amount of incident light. So reflection occurs when light strikes a material surface and causes changes in the direction of the light waves. There are two types of reflectance, specular and diffuse. So when you say specular, so as you see, when the when the light, okay, when the light strike the surface of a sample, it bounce back but in different direction. Okay? While diffuse reflection is when a light strike the surface of the sample, okay, the reflected, okay, lights goes to different direction, okay, different direction. So that is the difference between specular reflection and diffuse reflection. Okay, so let's have evolution of UVV's spectrophotometer. So in 1930s, vitamins research indicate that several vitamins, particularly vitamin A, absorb ultraviolet ultraviolet light. Okay, so with this um let's say observation, they want to determine or they want to determine how much ultraviolet lights absorbed by vitamins. So that's why they came up on idea to create a um instrument, okay, to determine the absorbed ultraviolet by um, of a substance, or let's say for example of the vitamins, particularly the vitamin A. So in 1941, okay, Beckman Deer spectrophotometers was first sold, okay, to produce, okay, by delivering more accurate results and reducing analysis time from hours or even weeks to minutes. So the first commercially available UV-Vis spectrophotometer are introduced in 1940 by Beckman and colleagues at National Technologies Laboratory. So it makes it makes them or it makes it as their first laboratory spectrophotometer. Okay, in 1950s, start of mass production reduced the cost of UV-Vis spectrophotometer. Okay, and then in 1963, JASCO introduced the ORD/UV-5 with double beam UV-Vis capabilities. In 1979, okay, launched the first commercially available diode array spectrophotometer. And then in 1980s, the proliferation of personal computer improves data acquisition and instrument control. And in 1990s, external software now provides PC control, on-screen spectra display, and spectra reprocessing and storage. So in early 2000, significant progress is made in the ability to measure microvolume liquid samples in biotechnology and pharmaceutical application. So in 2010, Thermo Specific introduced the evolution of 200 series spectrophotometer. So as every every 10 years, okay, there's a development um, there's a development to the UV-based spectrophotometer application, okay, and function. So future of UV-based spectrophotometer, okay, is um, future improvements of UV-based spectrometer will focus on ease of use, portability, and application specific instrument. So like for example, um, to measure or to analyze the solid samples and materials continues to grow in areas such as solar cell research, semiconductor products, and coating materials. So further development in remote sensor will enable more types of sample to be measured outside the laboratory. So that is the future of UV-based spectrophotometers.